In the following video, we will explain the final computational design assignment. I will divide my explanation in 6 sections. So we will start with creating a surface. We draw two curves in the Rhino model as a reference of the boundaries of the surface, and a third curve for the orientation of the model. Then we proceed with the creation of the grid of the facade. For this, we use a range domain, dividing it in 10 points using to create a gradient. Actually, we implement a sine function, and to adjust the sine function to the curves, we linearize. So we have a range from 0 to 1, which means from top to bottom. Then we proceed to create the connections in an horizontal way. For this, we actually use a flip matrix, which creates 16 lists of two reference points, 0 and 1, which will be consequently these two. In the same way, we will proceed with the vertical gradients, creating the horizontal lines, and then creating the flip matrix to create the horizontal lines. Then we explode our grid. So we have curves. Then we proceed to section number 2. We create the brick components. For this, is necessary actually to take as a reference our origin point to create our grid, and then retrieve it into our facade surface. Then we retrieve to one rectangle, we identify the plane, and then we assign the planes to the different uh, rectangles. Then we overscale our geometry, so we actually create our PV panels using as a reference these two values. Then we proceed with the rotation of our PV panels using as a reference the uh, vertical section. We explode our polylines. We identify the horizontal ways. We identify the middle point. We draw the axis of the rotation, and therefore we will have our middle point section rotation, and in the same way the other way around. As you can see, we have a problem. There's an overlapping of the PV panels. To solve this problem, first of all, um, we need to start from creating a volume. So as you can see, this is our original surface. We copy our surface, we loft it, we create a volume, and then we upscale it to create a more realistic situation. Then, using as a reference this volume, we take our PV panels that can be seen here. Um, then we deconstruct it, we recognize the points. Then, using a dispatch, we analyze and create a list of the points that are overlapping in reference to the surface. Then we BRAP to organize our middle points from the minimum to the highest range of distance as a reference of the surface. Then, deconstructed again, we identify the farthest point of our facade, and then we move all the points using as a reference this value to solve the surface problem. Then to create the volume of the PV panel on the brick, we use the reference of the original sections, and we loft them with the rotation of the PV panels. And that leaves us with the last section. We arrive into the solar analysis. For this, we are using a weather data document from New Delhi, India, using as a guidelines 12 month, 30 days per month, and 24 hours, and using our sky matrix here. And finally, our ladybug. We use as a reference the third curve that you can see in this section, which is here the north. Our geometry, that is our final love section. And we proceed with the late debug simulation. We use the maximum range because we're trying to